All right, let's do this thing. We've got another piece of vocabulary. Surprise, surprise. I'm telling you, that train never stops. It just keeps coming in statistics. There'll be vocabulary for the whole entire semester. So let's throw down what a complement is. This is a word. It's denoted by E to the C. I'm going to make this bigger here because I want you to see that. Because this is just a little part in here, and it seems like people forget this symbol and what you're using with that symbol. So that little C up at the top means complement, all right? So I'm trying to make it to where it's bigger, but not too big. So the complement here is all outcomes in the sample space that are not outcomes in event E. I ran out of space, didn't I? So the complement of E means everything but E. That's what it is. Well, complement is everything but what you're talking about. So the complement rule is if E represents any event and E to the C represents a complement of E, then the probability of getting E to the C is 1 minus the probability of E. Now tell me, why do I have a 1 in there? What does that 1 represent? All of it, right? Because remember, a probability is between 0 and 1 inclusive. The most you can have is 1. So if all together, right, and when we add those up, it's all together is a 1, then what's left over is going to be the complement. So I've got the total minus what it is I'm talking about because I want everything else left over, and that's a subtraction. So a complement is always, always, always 1 minus to get there. Okay, so according to the National Gambling Impact Study Commission, 52% of Americans have played state lotteries. What's a probability that a randomly selected American has not played the state lottery? Now, here's the deal. This is saying who has played. My question is who has not played. So I want the opposite, right? I want the opposite of what's going down here. So the probability they've not played the lottery, I forgot the R in there, I think, is 1 minus the fact that they have played. Because I want the other piece to it. And remember, that tells me a percentage up there, but is that how we write a probability? No way, it is not. We write a probability as a decimal. So this is 1 minus 0.52, which is a 0.48. So the probability that a randomly selected American has not played the lottery is 0.48. See what we're getting at there? Okay, that's a complement. Everything else, it is the symbol E to that little c, but did I have that symbol or that question in here? No, it's just talking about the opposite of what it is. So we have to know when it's talking about something different than what I'm given, that's automatic complement. So we're using our words here in order to make that happen. All right, check it. So the data in Table 7 represent income distribution of households in the U.S. in 2017. Here they are. This is how many in thousands made this amount of money in the U.S. So what happens? Anytime you try to figure out a probability, it's part over whole, right? So I have to figure out how many total. So if I add all of these up, and I get a total, like both columns, everything is just happen to be how it's set up. But everything, the whole total, how much you get out of that? 120,063. Check my math on that out of the calculator. Do you get the same thing? Okay, so that is my total in thousands, by the way. So that's my total in thousands. Now, We want to compute the probability that a randomly selected household earn the following incomes, 200,000 or more. There it is, 200,000 or more. The probability of 200,000 or more. We have that data right from our information. So what is it, 8284? Divided by our total, which is 120,063. We're going to take this to 3 decimal places again. What do you get? 0.069. Good. So right from the graph, right from the chart, that's information that we get right from there. Okay. Now, scoot this up. I still want to see that chart in there, but I want to see this next one. Now, what does this mean? Less than 200,000. So on the previous problems, when we were looking at this, we did less than 200,000. That would be every single one of these. I'm not going to try to do that. If you have the opposite, right, that you're looking at here, less than 200,000, it's all of these categories. I'm not about to try to add all those up. I know if this is the only one that's left, or if you have 1 or 2 that's left over, use the complement, because what I'm saying is everything that's not this. That's where the complement's amazing, right? Yes, I love it. Okay, so I'm going to squeeze this in a little bit so that I can write a little bit more. The probability of less than 200,000 is 1 minus, and simply because we just figured out this one, I'm going to use it. But it's 1 minus the probability of 200 or more. We just figured that out, so we're going to use that. No sense in doing work twice, right? I hear that. All right, and we get what? 0.931 is what I got. Is that what you got? Hope so. Okay, cool. What if I want to do at least 10 grand? Let's scoot this up a little bit. At least 10 grand. So 10 grand means all of this. Everything but that first category. So what do you think we can do? Yeah, doing the complement again. If you know one small piece and your goal is to have everything other than that, just use a complement. That's the beauty of the complement. So the probability of at least 10 grand is 1 minus the fact that we have 10 grand, and we haven't figured that one out. So we do actually have to figure this one. 120,063. So plug that into your handy dandy calculator. If you plug that into your handy dandy calculator, what do you get? 3 decimal places again. I have 0.935. Did I plug that in right? Good. Good. Nice. Right? Okay. What if I were to say, just because you know it always has you interpret what's going on, what if I were to interpret this? What does this mean? Out of 1,000 households, how many would I expect to be making less than 10 grand? A 1,000 households. How many would I expect? Or not less than, doggone it, at least. At least 935. Do you see what I'm getting at? I'm going to write it out just so that we have it. Out of 1,000 households, we would expect 3 places, 935 to be making at least, so 10 grand or more. Oh my, that looks terrible, doesn't it? Least 10 grand as a household income. See that? Okay. So it's always nice to interpret what it is that we're talking about. If I were to say out of 100, how many would you expect? 100 has 2 decimal places, so you'd say 93.5 or you'd say 94, right? Because you'd round it up to the next one. Okay, just want to make sure our interpretation doesn't take a back seat either. We're doing this, right? Look at all these cool things we're learning about probability. You guys are doing so good.